Welcome to Job Abhyas.
Relations and functions. Relations. A relation between sets A and B is a set of ordered pairs AB, where A belongs to set A and B belongs to set B. For example, if A is equal to set 1, 2, 3 and B is equal to set 4, 5, then a relation R from A to B could be set 1, 4, 2, 5. Types of relation. First one, empty relation. No elements of A are related to any elements of A, that is R is equal to 5. Let us consider a set A, xy. The empty relation on A, denoted as R is equal to 5, could have no ordered pairs. In set notation, it can be represented as R is equal to empty set. In this case, there are no relationships or connection between any elements x and y in the set A. The relation is empty, indicating that no elements from A are related to any other elements in A. Next relation, universal relation. Every element of A is related to every element of A, that is R is equal to A into A. Example, if A is equal to set AB, then the universal relation R could be R is equal to set AA, AB, BA, BB. Next relation is a reflexive relation. Every element is related to itself. For example, set 1, 1, 2, 2, 3, 3. Another type of relation is symmetric relation. If A and B is in a relation, then BA is also in a relation. For example, set 1, 2, 2, 1. Functions. A function is a special kind of relation where each element in the domain has exactly one image in the codomain. Suppose we have a set 1, 2, 3 as the domain and a set B, AB as the codomain. A function A from A to B would be a special kind of relation where each element in the domain has exactly one image in the codomain. F is to A to B. F of 1 is equal to A, F of 2 is equal to B, F of 3 is equal to C. In this case, every element in the domain A, 1, 2 and 3 has a unique image in the codomain B, A, B and C. This satisfies the condition of a function where each input is associated with exactly one output. Next is types of functions. First one is one-to-one injective function. A function f is to x to y is a 1, 1, or we can say it's an injective function if f of x1 is equal to f of x2, that is, or which implies x1 is equal to s2 for all x1 and x2 element x. For example, let us consider a function real numbers. We can define as f of x is equal to 2x. To show that this function is injective or one-to-one function, we need to demonstrate that if f of x1 is equal to f of x2, then x1 is equal to x2. Let's assume f of x1 is equal to f of x2, that is, f of x1 is equal to 2x1 and f of x2 is equal to 2x2. Now, if f of x1 is equal to f of x2, then we can return as 2x1 is equal to 2x2. We want to divide 2 on both sides, so we get x1 is equal to x2. So finally this shows that if f of x1 is equal to f of x2, then it will be x1 is equal to x2, proving that this function is a injective or one-to-one function. Another type of function is onto function or surjective function. A function f x to y is onto or surjective if given any y element y, x element x, such that f of x is equal to y. For example, let us consider a set 1, 5, 8, 9 and B 2, 4 and f is equal to set 1, 2, 5, 4, 8, 2, 9, 4. then we want to prove that f is a onto function. Given that a is equal to set 1, 5, 8, 9 and b is equal to set 2, 4 and given function f is equal to set 1, 2, 5, 4, 8, 2, 9, 4. So all the element on B has a domain element on A, or we can say that element 1 and 8 and 5 and 9 has the same range 2 and 4 respectively. Therefore, we can conclude that f is to A to B is a surjective function. Another type of function is one to one and on to, or we can say bijective function. A function f is to x to y is 1 1 and on to if f is both 1 1 and on to.